Here on behalf of my center, my first time in Moldova. It's a great day, and thanks for this kind invitation. So I'm Marcelo. I'm part of the International Center of Genetic Engineering and Biotechnology, which is an international organization that has more than 60 member states and 3 major laboratories in countries such as Italy, where we have headquarters in Trieste. We have a very big lab in New Delhi in India, as well as a lab in Cape Town in South Africa. And these are the countries that are highlighted in brown color on the map. Then we have more than 60 member states that are the green countries all around the world. And some of them, as you can see, are in pale green, and these are signatory countries such as Moldova. So these are countries that actually express an interest to join our center, but have yet to finalize their interest to become full members and to take full benefit of our activities. So what is this ICGB? So the ICGB is an international organization with the mandate to provide a center of excellence for research, training and technology transfer to industry in the field of biotechnology and to promote sustainable global development. So quite a broad mandate, mostly centered on biotechnology. If you have a look at the statute, although it's not clearly understandable from the slide, really, the focus is on the biotechnology, on doing research in the field of biotechnology for the interest of the member states, and to provide a framework to translate research findings into products, into bioproducts, into drugs, into effective drugs for health issues. The action of ICGB can be summarized in 5 major actions that are summarized here, and I will go through each of them in detail, trying to explain what are the major activities of our center. So the first and most important activity is scientific research, which is conducted in our laboratories in Italy, India, and South Africa. Really, what is critical and most important about our center is that it's not only a center for cooperation, for international cooperation at the political level, but it's also a research center. So we actually do research in our laboratories. And here is just a summary of the different laboratories that are at our centers in the 3 components of our institution. And you can see different topics in Trieste. We mostly deal with human diseases at the molecular level. In India, the focus is also on important topics for the countries such as malaria and tuberculosis. And in South Africa, which is a smaller center, we are dealing mostly with tuberculosis and parasitic diseases. For example, here I'm summarizing the different aspects of research that we are taking care of. We have programs in cardiovascular disorders, in cancer, in neurodegeneration, genetic diseases, plant biology, environment, and energy. Here I highlighted infectious diseases purely because I'm a virologist, so I'm interested in viruses, in infectious diseases. So the highlight will be on this particular topic. We, of course, publish our research in leading scientific journals. We transfer our findings into products. Here's an example of a diagnostic kit for dengue or drugs. And we patent our findings, such as a recently patented plant extract for the treatment of dengue virus. My group particularly is related to molecular biology. So this summarizes a little bit of our activities. We have activities at the basic level. So we are interested in HIV, so human immunodeficiency virus, and regulation of transcription, We have an interest in hepatitis C virus and the interaction of this virus with the innate immune response of the cell, and also more in general into flaviviruses, which is a huge class of pathogenic viruses. Our interest again is on the cellular response to the infection of these viruses. We also have a translational program for the development of diagnostic tests for flavivirus infection from traditional tests to multiparametric quantitative portable tests in point-of-care formats. We have also several core facilities at our centers. For example, I'm taking care of the core facility for fluorescent microscopy and for the biosafety level 3 for the manipulation of pathogenic viruses. These core facilities, which include also mass spectrometry, includes cytophronic analysis, and several other core facilities, are for the benefit of member states, so each member state can access this core facility for their own purposes in collaboration with our center. Just to summarize a little bit about our research, we're interested in flaviviruses. These include a number of important pathogenic viruses such as dengue, Zika, yellow fever. You may think, well, these are of interest for tropical countries. Well, it's not really true. We have endemic tick-borne encephalitis in Europe, Central Europe. I'm not sure about Moldavia per se, but I'm sure that in the woods here you will have also some prevalence of tick-borne encephalitis virus, which is a flavivirus, and also viruses such as West Nile virus, which may seem exotic, in fact is endemic in Europe, and particularly in Italy as well as Greece. We had a huge problem this summer for several cases and also several casualties related to West Nile virus infection causing neurological defects. So, although these are tropical diseases, these are important not only for travelers going to tropical countries and coming back, but also are becoming endemic, especially in Southern Europe. So we have an interest at the molecular level on the host cell response to these viruses and how these viruses kind of escape from the cellular response to infection. You know that cells tend to mount an antiviral response when these cells are infected, and viruses, of course, try to escape this response. And we first observed that there is a delay in the interferon response following tick-borne encephalitis virus infection, and we investigated the molecular basis of this delay. Here are just a few examples. We discovered that these viruses actually replicate in vesicles that are formed at the level of the endoplasmic reticulum, and these are electronic micrographs showing these specific compartments where the virus is able to replicate, and these vesicles kind of protect the replication from being recognized by specific pattern recognition receptor in the cytoplasm of the cell. But I won't go into the detail of this because of time constraints. How we are performing this research. So this is a picture of my group this year, this summer. As you may see, the composition of the group is quite heterogeneous. I have students from Africa, from Central and South America, from Greece, India, as well as Italy, of course. And what is most important is that this picture, although it was taken this summer, now the picture has already changed. There is a high turnover of people. So Khalid, he's Indian, who just left for the UK, where he's carrying out his research and career in the UK, and a guy from Nigeria joined us for a short-term fellowship for 3 months, and a postdoc from Brazil will join in October. So it's a highly dynamic and international environment where we do research in our laboratories in ICGB. How we are recruiting these people. This is done through an activity which is called advanced training, supported by long and short-term fellowship for PhD students and postdocs. This is something that each member state can access by sending their students and postdocs to our laboratories to get trained on specific topics of research. The program are called the Arturo Falaschi Fellowships. Arturo Falaschi was the initiator of the center and really the first Director General. The activities can be ICGB Fellowship, PhD fellowships, so fellows join the laboratories for 3 or 4 years for their doctoral studies, and then they receive a PhD in molecular biology from ICGB together in partnership with other universities. We have a postdoctoral program with fellowships for postdocs from member states. We have short-term fellowships. These are quite interesting because these allow scientists from member states that are particular needs for their research to join our center, for example, for performing, mass spectrometry or specific techniques in cytophotometry or fluorescent microscopy, and they can actually take advantage of our co-facility for their own research and then go back to their countries to carry on their work. And as well as we have the called SMART fellowship. These are fellowships that are for scientists from member states to go to another member state, not to join our center in Trieste, Delhi or Cape Town, but actually to move to other member states for their specific needs in research. We have a call every year for these fellowships. For PhDs, 1 call per year. For postdocs is 2 calls per year. For short terms, there are more than 2 calls per year. These are an example of the fellows on board in 2016. This is an example. As you can see, quite heterogeneous. Several countries are represented in from our fellows at ICGB. And this tells again how important it is to have a community of people from different countries, different backgrounds, but all with the same objective to do science at a high level for the benefit of the member states, the country of origin. And really our mission is to train and to sustain biotechnology in the different member states by training scientists that then could come back and bring their expertise back to their countries. Another important activity is organization of meetings, courses and workshops at the international level. And this again is done through a program where we have large meetings. We have workshops which are more focused meetings with less people, more focused on a specific topic. We have courses, training courses. We have an activity which is called the future of science, and these are more activities more towards the lay public, try to on specific topics that are of high importance and that are of interest for the general public. So we try to make some mixed meetings between scientists and the general public. And of course we can sponsor meetings. For example, this meeting can be sponsored by ICGB if you are a member state. You can ask for sponsorship for your specific interests and activities. Here we sponsor around 20 meetings per year, and we have a call every year for the meetings. And this is an example of a workshop that I organize every 2 years. This is a workshop on human RNA viruses. And we had this course since 2008. First was in Italy, in Trieste, then in Delhi, in Buenos Aires, in Argentina, in Istanbul, in Costa Rica, and this year will be in October in Shanghai, in China. And this is a representation of the participants of this course, this workshop. As you can see, again, quite a wide range of representatives participate to this workshop, and the idea is to make in different countries, in different member states, in order to attract people locally, providing access in geographic locations from South America, Central America to Europe or Asia. We still have to do it in Africa, but it's complicated, but we will do that once. Again, we have a call every year for meeting and courses, and this will be usually in February each year. Now, another activity which is also very important for scientists in member states are the competitive, so-called collaborative research grants, which are grants that are given to scientists in member states. So, for example, this is for whom you are running a lab or interested in doing research, they can actually access funding for your research through ICGB. So we have again a call every year, and the size of these grants is around 45,000 euro for a program of 3 years. And there are basically two specific grants. One is for senior researchers, so people that are already in the career in their own country and want to access funding for their research. And one activity is called early grants for researchers that return to their country of origin and want to initiate a laboratory over there. So we have both these programs for collaborative research programs. The fields are quite heterogeneous. The unifying theme would be biology, molecular biology, but it can be both basic science or more translational related to human health or environment or agriculture. So it's quite a wide range of topics. Again, these are the ongoing projects. Several different countries are actually taking advantage of this activity. And I'm showing here an example which I'm very fond of, which is a grant to Marcelo Baba. She's a researcher in Nigeria. She's working in Maiduguri, northeast Nigeria, which is one of the most troubled areas of the world due to terrorism. And she actually had to leave the country for several years. She's now back. She accessed this grant for doing a laboratory for diagnosis of blood viral infection in Maiduguri. We are collaborating with her by providing expertise and know-how for the development of diagnostic kits. So I think this is, for example, a survey that we performed on the prevalence of flavivirus in the area. There was no such activity before. Diagnosis for this kind of infection is not present at that location, and people that have fever are either treated for malaria or with antibiotics, and that's all. There's no kind of differential diagnosis of infection. Again, we have a call every year for the so-called collaborative research program grant. Is in April. We received more than 150 applications per year. We grant around 20, so it's quite competitive, but still it's accessible from member states. And the only criteria for selection is quality of the science that is being proposed. So finally, technology transfer. Part of the mandate of ICGB is actually to translate basic research findings into the biotechnology field and to actually collaborate with industry for the development of products of research. And well, you cannot read this, but this is just a list of patents that have been filed by ICGB researchers in the last years. And here is just a picture showing the collaboration with industry that is being undertaken by ICGB researchers. So there are several companies with whom we are collaborating, both for the production of, for example, diagnostic kits. These are examples of diagnostic kits for infectious diseases shown up there. These are ELISA kits or point-of-care stick tests for flavivirus detection. We have a collaboration for the development of antiviral drugs based on plant extracts. We have collaboration on other fields of research. What I'm particularly interested in is the development of point-of-care devices for diagnosis, and the concept is that diagnosis can be done in a centralized laboratory, such as what is happening mostly in Europe. We have centralized laboratory of diagnostics where you can run all the diagnostic tests for different diseases. The idea of point-of-care diseases is to bring the diagnosis to the patient, and in particular in an area where you don't have a capillary healthcare structure, you may want to have the diagnostics deployed at the site of infection, and this is particularly relevant during epidemic diseases where you need to have a quick response, a quick turnaround time response for containing epidemic cases. The way we do that is towards collaboration with industry. I'm showing just a couple of examples. We are developing, this is a real-time PCR prototype. Okay, this is the version 0.1 of our prototype for doing reverse transcription polymerase chain reaction on the field. We can do also serological assays based on LED technology, and this is an example of the detection of antibody-antigen bindings by a LED-based chip. Perhaps the most intriguing finding that we had recently is the development of this technology in collaboration with a company called Prof. They have this patent on a technology called reflective phantom interface. This is a label-free techniques for the detection of protein-protein interactions, and we applied this technique to the detection of antibody-antigen interactions. And the advantage is that you can run this on a chip, and you can run it simultaneously several spots for different diseases, and it's based basically on reflection. So if the chip would be totally transparent, but if you have binding, you will have increased reflection, and this can be measured. So simply the binding will be detected. You don't need any secondary antibody or labels to run the assay. And here's an example where we tested for West Nile virus and tick-borne encephalitis virus antibody response, and this is the kind of signal that we detect following the incubation of the chip with the sera containing the antibodies for these viruses. And the great thing about this technology is that can be applied to smartphone technology. I think all of you have a smartphone in their pocket, so you can use the smartphone. Each of you have a LED for doing your pictures and a camera, and basically you can use the LED to illuminate your sample and the camera to acquire the signal, and simply by applying this small device to your smartphone, you can actually run the assay. So it's quite cost effective because of all the technology for the electronics of the camera and the LED is done by Samsung, Apple, Lenovo, whatever. You just have to take care of the optics for doing the assay in a cuvette. So it's really a technology that can be very important and very useful for point-of-care diagnostics. Finally, we have a large program of biotechnology transfer, and this is for the production of so-called biosimilars. Biosimilars are products that are off patent and can be produced independently through a process that has to be, of course, formalized. In CGP in Trieste, we have programs for the production of different recombinant protein, such as interferon or growth factors, and the program is such as that we have the full process of production and validation of the product. Each member state, either companies in member state can access this program, so they can actually, let's say, buy the process. So we teach the company how to produce the product, and so they can actually go back to their country and produce the product in-house. And we offer the full cycle of production of each of these recombinant protein. And this is done through either bacterial or yeast platforms for purification or mammalian cell platforms for purification. But the important issue is not only the purification but also the validation according to the international standards. So we actually offer a product that can be used in the clinics, but no, we're not offering the product, we're offering the process. So then the biotechnology company in the member state can actually produce for their internal market a product that is fully validated. The field is really expanding because it's really expanding because the recombinant products are now shifting from standard interferon growth factors to recombinant antibodies or recombinant antibodies receptor hybrids for the treatment of cancer. These are also recombinant products that are coming out patent, and so you can actually produce biosimilars based on these products. And we are now shifting our efforts toward the production also of these kind of products that are quite important for the treatment of cancer. So I think I gave quite an overview of all the activities that we undertake at ICGB. I think we offer a number of advantages to our member countries that really are more than what we request from a member country in terms of fees, and really the range of activities that we offer cover both, people like students early on in their careers that wish to expand their expertise in different fields of molecular biology, to more senior scientists going back to their country to initiate their own labs, to senior scientists in their countries wishing to undertake specific research programs. We offer meetings, we offer workshops that can be organized in different member states, and we offer a full package of biotechnology products that can be produced in the member states. So I'm here for the full day. If you need any feedback on our work, I'm happy to address your questions. And thank you very much for your attention.